This Cisco Packet Tracer demonstration is for OSPF, Open Shortest Path First for Hexagonal Network Topology. This topology contains personal computers which each represents a /24 network. Each network is connected to its own router. The routers are connected with each other in a hexagonal topology. Each router-to-router connection is a /30 network. A central switch will be added that will directly connect with each router. The central switch to router connection will be a /28 network. All the personal computers in each /24 network will have its fourth octet in its IPv4 address to be 45, all of which has a 255, 255, 255, 0 subnet mask. The default gateway will have its fourth octet set to 1.
Each router will be connected to the central switch. Each router will use its Gigabit Ethernet 0/2 interface to connect to the central switch. The connection on the central switch will be a fast Ethernet interface. The fast Ethernet interface B will be 0/ the respective number of its connected router. For this topology, a central switch is not absolutely required. For this topology, the use of a central switch creates redundancy connections among the routers. Redundancy for network design is good for keeping the total network in operation in case individual connections are damaged or become non-functional. Now the network interfaces for each router will be configured. To be able to access the configuration terminal of a Cisco router, the EN command must be used followed by the CONFT command to specify an interface. The INT command is used followed by the interface's designation. For each router, the interfaces being used that need to be configured are Gigabit Interface 0/0, Serial Interface 0/3/0, Serial Interface 0/3/1 and Gigabit Interface 0/2. For each interface configuration, the IP address and subnet mask will be configured. For the Gigabit Interface 0/0, it is represented as G0/0 in the configuration terminal, which is preceded by the INT command. For the Serial Interface 0/3/0, it is represented as S0/3/0 in the configuration terminal, which is preceded by the INT command. For the Serial Interface 0/3/1, it is represented as S0/3/1 in the configuration terminal, which is preceded by the INT command. For the Gigabit Interface 0/2, it is represented as G0/2 in the configuration terminal, which is preceded by the INT command. For each router, the Gigabit Interface 0/0 is the default gateway for each PC. This interface will be configured using the network address of the PC's network, but with the fourth octet as 1. For example, for R1, the Gigabit Interface 0/0 IP address is 88.64.13.1. The subnet mask for the Gigabit Interface 0/0 for each router is 255.255.255.0, because each PC has a /24 network. For each router, the Gigabit Interface 0/2 will have an IP address of 155.155.12 with the fourth octet being each router's designated number, which would be 1, 2, 3, 4, 5, or 6. For example, for R1, the Gigabit Interface 0/2 IP address is 155.155.12. 1. The Gigabit Interface 0/2 for all routers are connected to the central switch, which is a /28 network, and thus would have a 255, 255, 255, 240 subnet mask. In a clockwise fashion, the serial interface 0/3/0 is on the clockwise side of the router. In a clockwise fashion, the serial interface 0/3/1 is on the counterclockwise side of each router. For the serial interface 0/3/0 for each router will have an IP address with the fourth octet being one integer higher than the fourth octet of its respected network address. For example, for R2, the serial interface 0/3/0 is connected to the 200.255.8 network, which will have an IP address of 200.255.9. For the serial interface 0/3/1 for each router will have an IP address with the fourth octet being two integers higher than the fourth octet of its respected network address. For example, for R2, the serial interface 0/3/1 connected to the 200.255.4 network, which will have an IP address of 200.255.6, since all serial interfaces are connected to a /30 network. The subnet mask for every serial interface will be 255, 255, 255, 252. The no-shut command is used to enable an interface and put its state to up. When a solid and working connection is made between two devices, the red triangles on the link between the two devices will become green. The exit command is used twice to get out of the configuration terminal. The copy run start command copies the current active configuration to the NVRAM. Ping tests will now be performed. PC6 can successfully ping router 6. However, PC6 cannot ping any PC on another network because after a packet is sent from PC6 to router 6 has no idea where to send the packet. This case is true for every PC in this topology. For full interconnectivity among all personal computers, OSPF, which stands for Open Shortest Path First, will be configured on each router. In the configuration terminal of each router, router OSPF1 will be configured for every router. For every network connected to each router's enabled interfaces, the network address and wildcard mask must be configured. Every network configuration will have area 0. The wildcard mask is the inverse of the subnet mask. Each personal computer is on a /24 network. The wildcard mask for a /24 network is 0, 0, 0, 255. All the serial interfaces are on a /30 network. The wildcard mask for a /30 network is 0, 0, 0, 3. The central switch is on a /28 network. For every router, the network address for the central switch connection is 155, 155, 12, 0. For every router, the wildcard mask for the interface connected with the central switch is 0, 0, 0, 15. OSPF is now configured on every router. Full interconnectivity among all devices is enabled. Ping tests are shown.